Hey guys, welcome to DSA-n-Design. Today we will look at how to merge two sorted linked lists into a single linked list, right? So how to merge two linked list, basically two sorted linked list in fact, right? Two sorted linked list. All right. This is what exactly we want to do it. All right. So let's try to understand what does it mean by two sorted linked list. So let's say linked list one is something like this. I have a couple of nodes, for example. Let's make 4 nodes here and link them each together, right? And so this is head node, let's say H1, and this is 2, 5, 10, and 15. All right. This is linked list 1. I have linked list 2 as well, which is kind of, let's say I have 3 nodes. Probably I'll take 3 nodes here, and they are also linked together, and this is basically my head 2, right? Head 2 means uh, head of the linked list 2, right? Now, if I say here 3 and 7 and 20, right? Now, this linked list, if you look at it, they are in sorted order, like 2, 5 in ascending order, right? Similarly, linked list 2 is also in sorted order. That is what it means, right? Now, what I want to basically do is we want to actually merge these two linked lists into one, right? My answer linked list should be what it should be. It should be basically, okay, how many are there? 7 nodes altogether. Let's make 7 node first. 4, 5, 6, 7. All right. Link it first and then we'll show you how it looks like, right? Now, the first value is basically 2, then 3, and then 5, 7, 10, 15, and 20. This is my answer linked list. This should be my answer linked list, right? Now, try to understand, guys, how we can actually achieve this, right? One thing is a very intuitive way that we can actually compare the each and every node of this two linked list, and whichever comes first, we will actually start making a chain of it, right? So something like this. Let's say I will create a answer linked list, right? And what I can do, maybe I'll take another pen, and then that is kind of can explain you better here, right? Let's take it. I don't know. Okay, this is fine. Now, for example, let's say I create a dummy node. For example, here this. Okay, I don't control Z. Okay, let's say I create a dummy node here, dummy node, and value with n. This is my dummy node. All right, value -1. Okay. Now what I will do, I will basically compare the head node and for head node, no, I will just say this is, let's say, my T1. Okay. I will just name, I will just say, because I don't want to manipulate with the head node, so I will just say T1 and T2, this node. Okay. I'll just assign the value starting this head node, right? So T1. Now I will say T1 dot value. So I'll compare basically, right? So two cases here, right? So I'll say if T1 dot value is less than T2 dot value, right? If this is the case, okay, my dummy node is here, right? And I also will do, what I will do, I will also assign this to answer. Same dummy node, I will say answer as well, okay? Answer node. Now, if this is the case, then I will not do anything with dummy node, but I will actually play around with answer node. I will move the answer node now, right? So if this is the case, then what I want to do, basically I want to link this answer node, sorry, this should be actually answer dot next, right? Answer dot next to be T1. Make sense? Now my answer node, which is here, it is actually going to be linked to this. Okay. Now, okay. After this, what I will do, I will actually move my T1 equal to next node. So T1 dot next. Make sense? I'll just move my this one, right? T1, correct, no? And then what I will do is I will just come out. I'll just move it T1 here. Now T1 is here basically. Now I'll compare these two again. If T2 is more, I will say else condition, right? If T1 value is kind of greater in this case what it is, right? So T1 value is 5 and this 3. And then in that case, what I will do, I will say, what I will say is, I will say answer.next equal to T2. And then I'll move equal to T2 equal to T2 dot next. Correct? Now my T2 will be actually here. Here, no? This is gone. Now again I will compare this, right? So now how it will look like. This is actually moved and now I will actually connect it to here, this one. Then again I'll compare this two. I'll find this is smaller. I'll compare it like this. I'll basically make a link to this, and after this I'll make a link to this, and then I'll compare this, something like this. It will happen, right? And this will be here, and finally. So you see that linked list is basically connecting properly, right? When we will code it, I think you'll be able to understand it in a very better way, right? Because I have to actually just compare these two value and keep linking to my answer value, okay? And finally, I have to actually return. I also have to return what? I have to return the head value. So I will say dn dot next, correct? Dn is actually -1, no? The next is basically this one, this value, right? So I will return basically what I will return? I'll return dn dot next, which is basically this particular node in this case, correct? So let's see how we can actually code this, okay? I think when we code it, I think we'll be able to appreciate it, okay? Let's try to do this. So what I will do is, I will basically say public, I'll make a function, public static node, and then in this case I'm actually getting two head node, right? Head 1 and head 2, correct? From linked list 1 and linked list 2, right? I'm getting just head node. Now what I will do, I will just create a dummy node. So I'll say node dn equal to new node. I'll just say, I'll just -1, take -1 value, right? Dummy node. And then I will also assign answer node, right? Answer node, answer ans, an maybe, answer node, okay? Answer node equal to what? Dummy node basically. That's what we did here, right? We assigned the same value, answer node equal to dummy node only, right? Just to start it, right? Now, the next step is I will actually store the head node, because I don't want to manipulate with the head node. Let the head node be the same place, point it. I will just assign, I'll take this head node into head node 1 into temp 1 and head node 2 into temp 2. Okay. Now I will actually use this temp 1 and temp 2 to traverse the linked list. Make sense? Okay. Now I'm done. What I will do, now I will say while my temp 1, until I traverse whole linked list, my temp 1 is null. Okay. Okay. Until my temp node is not null, I will traverse either temp 1 or temp 2. Either one of them reach to the last node, I will stop it actually. Okay. So in this case, I'll say one of the condition is false, then I will actually come out of it, right? Otherwise, I'll continue to actually compare these two nodes, right? Something like this you can see here, right? So until I reach to here, I will not stop. Actually, I have to compare it. One of the linked list is exhausted, that moment I will stop, and then I will see the what next I have to do, right? So first let's try. So this is the condition, okay? Hope you understand it. Now what I will do is, I will try to compare it now, right? So I'll say temp1 dot val is less than temp2 dot val, right? If this is the case, if this is the case, then what I'm going to do? I'm going to say answer dot next, because answer is pointing to what? Dummy, which is -1. I will say that I will actually connect this dummy node, right? It will connect to the lowest value. That's how I started making chain, no? So I'll say the minimum value. What is the minimum value? In this case, I'm say temp dot one value is minimum, no? So I'll say temp1 dot val. Make sense? This is not answer, guys. This is an basically answer node, no? This one. This is done. Now what I will do is, once if you see here, I actually connected it, no? But then at the same time, I also have to, after connecting to this, right? I have to move my answer node. This answer node, okay, I connected it, but I also have to move this particular node, right? so that I can connect to the next one, right? So what I will do, I will also move it answer equal to temp1. Okay, I move to this particular node actually. The answer is now pointing to this one, this particular node, okay, which is the first node, a smaller one, right? Now, what I will say, I will also, now this point of time, I'll actually move to the temp1 next. So, what happened after this line? Actually, T1 is moved to here. Temp is moved to here. My answer is still pointing to here. Okay. Now I will compare this one, and then based on that, I will again link my answer. So in this case, what I'm saying, I'm done with this, right? Now there could be else condition, no? After if, there could be else where my temp1 is what? Equal to or greater than temp2, correct? This could be the value. If temp1 is greater, then what should be my minimum value? Then I will actually say answer dot next equal to temp2, because temp2 is going to be smaller value in else case, right? And I will move again an to temp2 basically, correct? Same way how I move to here. We will do the dry run, guys, and then we will see that. Now just try to understand what I'm trying to do it here. Okay. Now temp2 dot next. Making sense? Now this is what we are actually done up to while loop. Okay, while loop. I'll come out of here. Okay. Now if you look at it, one of this linked list. Okay, if I can clearly show it, let's say I compare here, right? And then finally I'm actually I went here and I connected to this, right? And the next one, I'm kind of exhausting one of the linked list. I'm exhausted, correct? One of the linked list, the moment I exhausted, what I will do, I still have another linked list, isn't it? I don't know whether I can. Okay, I can do one thing. Okay, let me do one thing. Let me code it, guys. Then I can actually do a dry run, and then you can actually appreciate this thing, right? So let's say one of the linked list is exhausted. I will come out of this while loop. But then again, for the remainder of remaining elements, remaining nodes, I will still have to travel, no, to link them. So I'll say temp1, okay, not equal to null. Okay, let's see. So what I will do, I will say an dot next equal to temp1, all right, and then I'll say temp1 equal to temp1 dot next. This is what I have to do. Okay, similar way, let's say another linked list for let's say T2, no? So for T2 what we have started, temp2, no? Here I'll just replace it, guys. Okay, for T2 also we have to run the similar way. Okay, I'll show you why we need this additional two while loop as well. And then finally what I will do, once this is done, no, I will actually just return. What I will return? I will return what? I will return dummy dot next, because dummy is still here. See, I am not playing with dummy. Dummy is still the same -1, pointing to -1. I am just actually moving my answer pointer, right? Answer node. So my dummy next, when I say, that is the very first pointer, which is my head actually, right? So I'll say I'll return dn dot next. That's it. That's all basically we need to do here. Is it dn dot next? Correct, no? Public static. Why it is not okay? Public is it? Yeah, public static node. Oh, sorry. I think wrong. Okay, I'll say merge sorted linked list. Okay, now this will work. Okay, now what I will do, I will actually go and create. I will just call this function. Okay. Let me see if I already have two linked lists created here. Okay, so I have linked list 1 created, which is pointing to head 1, and linked list 2 created, which is actually pointing to head 2, and 3, 8, 11, and 40 are the elements here, 5 elements, and here 2, 5, 10, 12, 50, right? These are the elements here. Okay, let's do one thing. Let's basically call this. What I will do is I will actually copy paste it, so that I want to display, right, after that, right? So I'll say after, I will say sorted, merged, merged linked list. Okay, something like this I will say. And here guys, what I will say is, I will do is, basically this is the one, no? I'll just store into node answer, something like this. And here I'll pass head 1, comma head 2. Correct? Head 1 and head 2. And now this is my final head. Answer head I will say here. Maybe answer head. Okay. I'll just say, and I'll pass the answer head here and then print the entire shorted linked list. I think this will work. Let's try to understand. Let's try to run and see the output actually. Okay. If I can run it here. Oh, okay. Okay, here guys. I should actually forgot it. Yeah. Now see. Oops, somewhere it went wrong. Incomplete int cannot be converted where it is. And dot. Oh, sorry. I think this should not be value actually. Okay. This should be. This is just node, no? So, okay. And okay, this is fine actually. Okay. What about here? Hopefully this works fine now this time. Let's see. Nice, fantastic. You see that? Now, if you see it clearly, you see it clearly, 2, 5, 10, 12, 50, and the second linked list is 3, 8, 11, 40. Now you see after sorting 2, 3, 5, 8, 10, 11, 12, and 40. Now, one thing you might be noticing, where is my node number 50? We are missing 50, no? What is the problem with 50, guys? Is there any problem with node 50? Let's try to see. Okay, not here, maybe somewhere in my coding maybe guys. Let's try to dig into this loop basically. an dot next equal to temp2 okay, dn dot next fine is not null. Oh, here where it is. Okay, sorry. All right, okay. Okay, sorry, I just missed it actually. Okay, what I have to do, I forgot to run another while loop actually. I just said no, we have to run both the loop here. So I have to say for temp1, the leftover element also need to be handled actually here, no? I can just say it. Maybe now this might work. Let's see. Perfect, perfect. You see, all the elements are coming now, including 50. Okay. Now, let's try to do a quick dry run and we will try to understand it, guys, right? What I'm doing is quick dry run. Okay. I'll just show you here. Maybe I'll just take it. I'll take with a very small 2, 3 elements maybe that will work. 3 elements and 2 elements, for example. So if I say link list 1, okay, I have 3 elements, for example, 3 nodes, not element. Okay, maybe 2, 5, and 20. Fine. Now link list 2, it is having let's say 3 and 12. Fine. Now sorted linked list will be how? It will be basically 1, 2, 3, 4, and 5. Obviously 5 nodes, no? This should be my answer linked list. So this will be 2, 3, 5, 12, and 20. Correct? This is my answer linked list. Correct? This is what I am expected to do. Now let's try to do the. I think it will be difficult to actually go and show you the code as well. But let me dry run it. What exactly it means? Okay. So let's say this is my here is my dummy node. Okay. Let's say here is my dummy node, or this is also answer node an. Okay. And the value of this is -1. Fine. Now let it be. We are assigning it first. Now this is my T1 and this is my T2. Fine. Now I compare value of T1 and T2. Okay, if it is T1 is less than T2, T2 value, then I am going to link this to T1. Fine. After linking, what I will do is I will also move my AN. AN is still pointing to this. I will move my AN here. Okay. This is what we want to do. And my after this comparing, no, I also move to T2, T1 here basically. Now you see AN is here, T1 and T2. Again I'll compare these two. I found this time T2 is actually smaller. Then what I will do? Similar way, I will actually link my AN to a smaller value which is here. I'll link this and I'll move my AN here again. Okay. My T2 will be moved to next. So T2 will be here. Agree? Now I'll compare these two. T1 and T2. I found that T1 is actually smaller this time. So what I will do, I will actually next of AN will be this. So I will be actually moving my linking my AN to this, and I at the same time I'll move my AN answer node here. Okay. Now look, my T1 is here, correct? One second, one second. What did I say? After T2. Okay, fine. Uh, T2, no? T2. Yes, exactly. My T2 is moved here. Now again, what I will do, I'll compare these two. I'll compare T1 and T2. I found T1 is smaller, right? One second. I think I just did the same thing, no? Ha. Okay, 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 okay. So I actually what I did, I compared these two, T1 and T2. I found that okay, uh, T1 value is smaller, then I actually link to this, and then I will move T1 here, no? T1 will be next actually, okay? And my AN, where AN? AN is already moved here. This is fine. Now what I will do, I will actually compare T1 and T2 both. The moment I compare T1 and T2, I found T2 is actually smaller. Then my AN will be connected to here. Okay, AN will also will move to here actually. Okay, fine. Now, mm, what I'm going to do is basically I'm going to at the same time I'm going to move my T2 because T2 is smaller. I'll move my T2 next actually. So my T2 actually going to point to null. This is going to null actually. Now T2 is pointing to null value. The moment it is pointing to null value, I'll come out of this loop, right? Here, if you see here, the moment one of the condition is false because I'm actually checking T1 and T2 both should be not null. Now T2 means temp2 become null. I'll come out of it. I'll come out of it, and what I will do now, this code will play a role. Now look at it here. The moment I came out of it, my link list is where? My link list is actually up to here. So I am able to connect what? -1. Okay. Okay, I'll just write it, guys. Okay, -1 and then 2 and 3 and 5 and 12. I'm able to connect this, correct? Up to this. But I'm not able to connect to this one. T2, 20 value in T1 because my T1 list is still having not pointing to null. It is still pointing to value 20 or this particular last node, right? And that's where I say I will actually run. I don't know which one is actually gone null, right? That's why for the safety I am actually running both the loops. So now what will happen? It will check whether temp is not null. Yes, it is not null. Then what I will say? I will say add this again. So if I come here, it will check, okay, my temp is not null. Then I will actually say that, okay, currently my AN is pointing here. I will actually point to this one because this is still not null. So I will move it here actually, okay. As part of this code actually, it will move also, no? See, AN next equal to this and temp will be moving to this one, right? Correct. Temp is actually moving to this one. It moved actually. Now what happened? Uh, the moment it moved here, it is now going to point to null actually. The T1 will also be moved and T1 actually going outside this particular node and this is null again. Now both of this is null. So this is actually, this got null, right? Now T1 is null. For example, T1 is null. It will come out of it. Again, it will go to T2 and check whether it is null. Yes, T2 is already null actually. It will know nothing actually here, right? and it will come out of this loop as well, and it will return dn.next. Now you see that my link list is very nicely actually linked. Now it is going to be 20, right? As per we connected it, no? Now my dn was still pointing here, isn't it? Because this was my dn. We did not touch any dn node. Now I'm saying dn.next. I'm saying return dn.next, return, right? What I'm going to return? I'm going to return this particular node. So this is my head node of the linked list. That's what I'm going to return. And now this is going to be my resultant linked list. Nicely, right? You can understand it, right? So this is how actually we can actually what you can we can actually merge two sorted linked list. Okay, so this code is very important. Yeah, so this is what we are done actually. We are able to do it in what? Okay, now let's discuss quickly in 2 minutes what exactly is the time complexity. Time complexity is basically what? Here the time complexity is order of n plus m. For example, there are n node, like this particular L linked list one. Let's say there are n nodes and here m node, and then my overall time complexity is going to be sorry, not time complexity. I'll say space complexity, guys. Time complexity is still we have to visit everything, no? Time complexity is also same, okay? Time complexity is order of m plus n, and space complexity is also order of n plus m. Okay. Now the challenge here is what we have done. We have created a brand new linked list basically, and that is what is my new linked list or the sorted linked list it is, right? So that's where we are creating. Now in the next example we will actually solve the same question, pretty much same question, but what we will do is we will not use this space complexity as kind of n plus m. Okay, we will not use this space complexity. Rather, in the next kind of problem, same problem, we will actually solve it in actually order of 1. We will not use the extra linked list. Rather, we will be actually manipulating the same link. We will be linking, delinking, etc. We will be using these two linked list only, whatever is given. We will not use the extra sorted linked list. Okay, what we have done actually here, no? So we have just compared it and we linked with the extra linked list, and which is taking extra space n plus m. We will not do that. We will rather actually solve in order of 1 time space complexity. Okay, so that's all we want to do in this video. I hope that this is helpful for you guys. I think let me know if you have any question on this, and if you are first time visiting this channel, please subscribe so that it can give me a lot of encouragement to do more and more such kind of videos to you. All right, so until we meet next time, bye.